we have discussed about the what position time graph and velocity time graph. We have discussed all what slope will give you, area will give you, everything. And today we are going to discuss one more very important graph, that is acceleration time graph. So in velocity time graph, what we have done, we have taken velocity along the y-axis and time along the x-axis. So same thing here. Here along the y-axis we are going to take acceleration, along the x-axis we are going to take time. Okay. So acceleration time graph. So I can write it as simply AT graph. We can write it as AT graph. Okay. So what is AT graph? So if this is the coordinate system, x-axis and y-axis, so along the x-axis we are going to take time, and along the y-axis we are going to take acceleration. Acceleration is taken along y-axis and time is taken along the x-axis. Then the graph is called as what? Graph is called as AT graph. So how we can define the acceleration time graph? The graph in which acceleration is taken along y-axis and time is taken along. Same definitions which we have done for similar definitions what you have done for velocity and position. Okay. So time is taken along what? Along x. So time is taken along x-axis. Okay. The graph in which acceleration is taken along y-axis, time is taken along the x-axis is called acceleration time graph, or simply you can say AT graph. Okay. So this is what the definition of acceleration time graph. Suppose if so this is what the origin and body is moving in this direction. So directly if accelerations are given, say acceleration, say here it is 0, here acceleration is going to be say 10, here acceleration is going to be say some 30, here acceleration is going to be say some 50 or some 60. Okay. So here acceleration is going to be say some 100, here acceleration is going to be say some 150. So what is unit of acceleration? Meter per second square for all. So directly what is given? Acceleration is given. Similarly time is going to be here. It is say some 10 seconds, some 20 seconds, 30 seconds, 40 seconds and 50 seconds. Okay, this is what the time is given, and acceleration is also given. Usually they won't give you the acceleration directly. Just I am taking a simple example. They will give you the velocities. You have to calculate the acceleration. Then you have to make your own data. Then you have to plot the graph. Okay. As of now, no problem. What is there? Directly they have given the acceleration. Okay. So if I plot the graph over here, so this is what acceleration along y-axis, time along x-axis. So 10, 20, 30, 40, 50. So here we want till 150. 150 in the sense I will take say some 20, 40, 60, 80, 100, 140, 160. Okay. So these are the what value of accelerations. So first, when time is 10, acceleration is 10. So 10 will come between 0 and 20. So I will take it here. This is what the point. This is what the point. Okay. Then 20, 30. So 30 will come between 20 and 40. So it may be somewhere here. So this is what. Okay. This is one more point. Then for 30, 60 it is. For 30, 60 it is. For 30, 60 it is. Okay. then for 40, 100 it is 40, 100 it is okay. So for 40, 100 it is. Then for 50, 150. So for 50, 150 here it is. So this is what we, for 50 it is going to be 150. Okay. So this is what graph we got. So just you have to join it. It may take the what some different shape also. No need to worry about that one. So this is what the graph you got for the acceleration time. Okay. Here it is not uniformly accelerated also, or you cannot comment something on this one because acceleration is variable. Simply you can say it is a variable acceleration or non-uniformly accelerated motion. Acceleration is changing like anything. Okay. So this is what the graph. So very important thing is what the slope will give you. The slope of AT graph. Suppose you are having the acceleration time graph over here. If suppose you are having the acceleration time graph, what this slope will give you? What this slope will give you? Okay. So slope means here what will come? Here change in acceleration will come. Here what will come? Change in time will come. Okay. So similarly here, if you take the slope over here, so what slope will give? This is what? This is change in acceleration. If you take A, B, C, this is what change in acceleration. This is what change in time. Along this you will get it as change in time. So slope is equals to what? Slope is equals to AB divided by BC. What is AB? AB is delta A divided by what is the denominator, delta T. Okay. That means slope is change in acceleration divided by time taken, or you can say change in time. Okay. So this particular slope, the rate of or change in acceleration divided by change in time, it is called as jerk. It is called as jerk. Remember this word. This is called as jerk. It is not there much for the syllabus, but we should know what the slope of AT graph gives. The slope of AT graph gives you jerk. Okay. So the slope of, remember this, the slope of AT graph, acceleration time graph gives, what? It will give jerk. Okay. Then what do you mean by jerk? What is this? Change in acceleration divided by change in time or time taken. What it is called? It is nothing but rate of change of acceleration. So slope is what? Slope is rate of change of acceleration. What slope is called? It is jerk. So jerk is what? Jerk is nothing but it is rate of change of acceleration. Rate of change of acceleration with respect to time. Rate of change of acceleration with respect to time is called as what? Is called as jerk. Remember, very important. So jerk is what? Rate of change of acceleration with respect to time. Okay, because slope is giving that one only, change in acceleration divided by change in time. Okay, so this is what the slope of acceleration time graph gives. What is that? That is nothing but jerk. Okay. Now one more question arises: what area under the curve gives you? What area under curve gives you? Area under the curve. So what area under the curve gives you? Suppose if I take that only here, if I take that example only. So what we have acceleration here and time here. Okay. So this is what. So if you want to calculate area, okay. So this is what going to be our area. So you have to calculate this area. Okay. So means from here to here, what it is acceleration, from here to here what it is time taken. Okay. If I calculate area under the curve, what it is nothing but area of triangle A B C. Okay, so it is nothing but area of triangle A B C. So what is area of triangle A B C? It is nothing but half into height into base. Okay, so what is height? Height is A into base is what? Base is time. Okay, so half is a constant, no need to worry about that one, I will not consider that. Acceleration, can you write acceleration A equals to velocity divided by time? Because acceleration is what? Rate of change of velocity with respect to time. So A equals to V by T. So what I can write here, I am not writing this constant, so acceleration is what? I can write it as V divided by T. So one more T is there, so T will get cancelled. So what you will get? You will get it as V. So area under curves gives you what? Area under curves gives you velocity. Remember, slope of AT graphs gives you what? Jerk. Area of or area under the curve of acceleration time gives you what? It will give you the velocity, because it is nothing but acceleration into time. Time will get cancelled. You will get the velocity. Okay, so note that point. So area under the curve of acceleration time graph. Acceleration time graph gives what? It will gives velocity. Okay, so area under the curve gives the velocity and slope of the curve gives you jerk. Okay, so now we'll plot the graph for uniformly accelerated motion and non-uniformly accelerated motion. So if I take an example, so if suppose body is moving in this direction, here it is 0. So obviously now I will not give you what acceleration, I will give you the velocities. Okay, so here it is say 10, here it is say 20, 30, 40, 50. This is what velocities, meter per second means what? Velocity. Okay, so time what you can take? Time you can take 1 second, 2 second, 3 second, 4 second, 5 second. Okay, time is given, but what we have to plot? We have to plot the graph of acceleration versus time. Okay, so for that we need acceleration. So acceleration is not given here, so you have to calculate acceleration. Calculate acceleration means what? It is delta V by delta T. So delta V, 10 minus 0 divided by 1 minus 0. So 1 minus 0. So this will become what? This will become 10 by 1, that is 10 meter per second. Okay. So this is what? Meter per second squared. This is what for this interval. So here it is 20 minus 10. 20 minus 10 divided by 2 minus 2. So 2 minus 1. So what you will get? You will get it as, so again this is what 20 minus 10 divided by 2 minus 1, again you will get 10 meter per second. Here 30 minus 20 divided by 3 minus 2. So again what you will get? You will get it as 10 meter per second square. Okay. Similarly 40 minus 30 divided by 4 minus 3, you will get 10 meter per second square. So 50 minus 40 divided by 5 minus 4, again you will get 10 meter per second square. So if you look at the values of accelerations, so accelerations are going to be what? Same. So it is what? A is constant. So if you plot the graph of acceleration versus time, so what will happen? This is what? 1, 2, 3, 4, 5. 1 second, 2 second, 3 second, 4 second, 5 second. Here, acceleration you have to take, say, this you can take some 5 meter per second square, some 10 meter per second square, 15 meter per second square, 20 meter per second square. When time is 1 second, don't look at this value, look at this value. It is 10 meter per second square, so it is going to be here. This is what, okay. So for time equals to 2 seconds, again value is what, 10. So again it is going to be what, it is going to be 10 only, okay. So similarly for 3 seconds it is going to be again 10 only. So this is 10. For 4 also it is what, it is going to be 10. For 5 also it is going to be 10. These are the what values of acceleration. So if you plot the graph becomes a straight line parallel to what? Parallel to x-axis, parallel to time axis. So what this is showing? This is showing acceleration is constant. Acceleration is constant. What slope will become? Slope will become 0, because you cannot calculate slope over here, okay. You may calculate area and other curve, but you cannot calculate what, you cannot calculate the what slope, okay. Slope is going to be 0. So now if acceleration is constant, what you can call for that one? You can call for that is uniformly accelerated motion. Uniformly accelerated motion. So this is what graph of uniformly accelerated motion, okay. So uniformly accelerated motion, okay. So this is what graph for uniformly accelerated motion. If you want to calculate velocity, you can calculate, you can find the area. So what area you can get? This is what the area. So total area is what? Area is going to be this is what area of rectangle. So this is what 10, and this is total is what 5, okay. So 50 meter per second is going to be what? It is going to be velocity, average velocity over the whole journey, average velocity over the whole journey. So that is going to be around 50 meter per second. So that we will see in coming examples. But as of now, remember, if a graph is going to be some constant value, some line parallel to x-axis, then it is said to be what? It is uniformly accelerated motion. Usually, if it is VT graph, if you get like graph like this, then you can say that you will get slope everywhere constant. This slope will give you what? Acceleration. So then you can say that it is the uniformly accelerated motion. For what? For what? Velocity versus time graph. But here it is acceleration versus time graph, okay. If you get a graph like this in acceleration time graph, that is not the uniformly accelerated. If you get the constant value, then only you can say it is the uniformly accelerated motion, okay. So now we can take an example for non-uniformly accelerated motion also. Non-uniformly accelerated motion, okay. So non-uniformly accelerated motion, you can take any value. So simply I will take, say, so if I take an example over here, so it started from 0, so velocities and time is 1 second, 2 second, 3 second, 4 second, 5 seconds. So velocity here it will become 10, and then here it will become, say, some 30. So after that it will become, say, some 60. So here it will become, say, some 90. Now here it will become, say, some 150 or 140. Okay. So this is what the value is given. This is velocities meter per second. This is time. What you have to calculate? We have to calculate the acceleration. So acceleration for first is 10 minus 0 divided by 1 minus 0. So it is 10 meter per second square. Here 30 minus 10, 20, 2 minus 1 is 1. So this is going to be 20 meter per second square. So 60 minus 30 is 30, 3 minus 2 is 1. So this is going to be 30 meter per second square. So now 90 minus 60, again it is going to be 30 meter per second square. 140 minus 90, that means it is going to be, say, some 50 meter per second square. Okay. So this is what the values of accelerations You have to plot these values versus time, not these values. These are what velocities, okay? So whenever they use velocities, if you want to plot the graph of acceleration time, we have to calculate acceleration. So plot the graph of acceleration versus time, okay? So this is what acceleration and time. So I will take time as 1, 2, 3, 4, 5, and accelerations I will take here. So how long for you? I want till 50. So 10, 20, 30, say 40, say 50. This is what acceleration along y-axis, time along x-axis. So what is that? So when time is 1 second, acceleration is 10. So this is what first point. When time is 2, so acceleration is going to be what, 20. So for 2 time it is going to be 20. Okay. So alright. This is going to be what, 20. Then for 3 seconds it is again 30. So for 3 seconds it is 30. Okay. So again for 4th second, again it is 30 only. So again it is 30 only. 30 only. For 5th second it is going to be 50. So suddenly it comes to 50 over here. So 40 is not there. No need to worry about that. So this is what. So if you join the lines over here, this is what line is. So here it goes to some 30, 10, 20, 30, then again 30 remains same, again it will come here. So acceleration is variable. Here it is say some 10, suddenly it becomes 30, suddenly it becomes 50. So this is what acceleration is not constant. Okay. So acceleration is not constant. Okay. So that is why it is the graph of non-uniformly accelerated motion. So this is what the graph for non-uniformly accelerated motion, and this is for uniformly accelerated motion. Here slope is going to be what, 0. That means jerk is 0. You are not going to get any rate of change of acceleration. But here you can calculate the slope. You can calculate the slope, and you will get what? You will get jerk. You will get the rate of change of acceleration. Okay. So these are the graphs for uniformly accelerated motion and non-uniformly accelerated motion. Okay, if now I draw the graph for freely falling body. Okay, freely falling body. Freely falling means under gravitation. Suppose a body drop from, suppose you are standing on some building over here, and you are standing over here. Obviously, not to jump, so you will drop a ball over here. Okay. So if you drop the ball, what will happen? As ball reaches to surface, its velocity go on increasing. Okay. So now here it is what? It is say velocity is 0 here. So when it comes here, it may say velocity will become say some 20. When it comes here, velocity may become say some suddenly some 70. Here when it comes here near to ground, say velocity may be say some 150. Okay. So velocity go on increasing, meter per second, meter per second, meter per second. Okay. So this is for first second. So t equals to 1 second. This is for t equals to 2 seconds. This is for t equals to 3 seconds. Okay. Now, if you want to plot the graph of acceleration time, what is acceleration here? Acceleration is going to be 20 minus 0 divided by 1 minus 0. So it is 20 meter per second square. Similarly here, 17 minus 20 divided by say 2 minus 1. So this is going to be what? Some 50 meter per second square. So here 150 minus say 150 minus 70. 150 minus 70 divided by say 3 minus 2. So what you will get? You will get 150 minus 70 means 80. So 80 meter per second square. Yes or no? So 30. So it is 180. Now if you plot the graph, so what graph you will get? You will get the graph something like this. So this is what acceleration and time. Time, how many are there? 3 are there. So 1, 2, 3. 1, 2, 3. So if you want, you can take 4 also. So here you want till 80 you want. That means I will take it here. It as 20, 40, 60, 80, 100 if you want. Okay, these are what accelerations. So now plot the graph for 1 second, 20 meter per second square. Okay, for 2 seconds, 50 meter per second square. So it is here somewhere, 50 meter per second square. For 80, third second it is 80. So this is what. This is what 80. So if you just join them. So here it was 0 and when it was in your hand. When you drop it, velocity go on increasing as it reaches the ground. So that is how you are getting the what? You are getting the line which is passing through the origin. You can calculate slope also here. You will get some positive slope, means some positive jerk. So slope will be what? Positive here. So if you calculate, you can get the slope over here. So slope will give you what? Jerk. Between 1 to 2 seconds, what is the jerk? Between 2 to 3 seconds, what is the jerk? That you can calculate. Okay. Now if I take the slope over here, what it will be? Slope will be 50 minus 20. Slope will be 50 minus 20 divided by 2 minus 1. 2 minus 1. So this will be what? This will be 50 minus 20 will be 30. Unit is what? Acceleration is what? Meter per second square. Already one more second is there. So this will become meter per second cube, something like that. So that is not there for our syllabus, but we should know what it will give. Jerk. So jerk may be variable because it seems to be slopes may be different. Okay. So similarly, you can calculate area also. If you calculate area under this hole or if area under this one, you will get what? You will get the velocity. Okay. If they ask you to calculate velocity, you have to calculate what? You have to calculate area under the curve.